Hello, everyone. My name is Richard Zucker, and for 43 years I was known as Professor Zucker when I taught mathematics at Southern California community colleges. I'm retired now, but I still have that urge to teach, and that's one reason why I'm making this video. But there's another reason. A few weeks ago, a neighbor of mine had just come back from getting his second Pfizer vaccine shot, and he said, "I'm now 95% protected." I asked him what he meant by that, and he said, "Well, the Pfizer vaccine is 95% effective, so I guess I have a 95% chance of staying healthy and only a 5% chance of getting COVID-19. One of the reasons why I love teaching math is that math is often at odds with common sense. My neighbor had given me a common sense answer, but we'll soon see that the math tells a very different story. And that's the real reason why I'm making this video. Before we go on, I think we need to address the elephant in the room. This subject of COVID-19 and the vaccines is an emotionally loaded one. We live in scary and uncertain times. I just want you to know that this video is not about whether I approve or disapprove of the vaccines. I'm just trying to clarify what the numbers mean. So in this video, I'm going to show you 3 measures of a vaccine's effectiveness. I'm going to compare the Pfizer Covid-19 vaccine with the measles vaccine, and we'll see that by one measure, they have exactly the same effectiveness. But by the other 2 measures, they are very different. And at the end of the video, I'll return to my neighbor's comment and share with you what he could have said to be mathematically accurate. So stay tuned. Now, before we talk about the Pfizer COVID vaccine, let's go back in time and talk about the measles. And it'll be an interesting comparison because, as I will show you, I'm going to spill the beans right now, measles has an efficacy, I shouldn't say measles, but the measles vaccine has an efficacy of 95%, exactly the same as what we've heard in the news about the Pfizer vaccine. Well, let's see why, and then we'll go beyond that with a few other numbers as well. So here we have a little graduated cylinder to indicate the whole population. The population in this case would be the children from 0 to 15 years old, because those are the ones that are most affected by the measles. In fact, the measles had an incidence of 90% in that population before the vaccine was introduced. So let's put a little arrow here at 90%. I know it says milliliters, just change that into percent, referring to the population. After the vaccine was licensed in 1963, the incidence of measles fell dramatically down to just 4.5%, which in this picture would be, let's see, each line is 2, so it'd be a little bit more than that. Okay, that's about 4.5%. Okay, so let's talk first about the ARR, the absolute risk reduction. Well, the absolute risk reduction is the percentage of the population that benefits from being vaccinated. Well, we can calculate that in a couple of ways. Here's one thing we can do. Let me change colors here for a moment. What if I take a look at the people who don't benefit? You know, there were 10% of the population right here. That 10% were somehow immune to measles to begin with. They didn't get sick. So they certainly don't benefit from the vaccine. And the 4.5% way down here, well, those people, those are the people that get sick even though they got the vaccine, so they don't get the benefit of the vaccine either. So the people that do get the benefit of the vaccine, well, that's on the graduated cylinder, everybody in between. And we can find that by just taking the 10 and the 4.5, adding them together and subtracting it from 100%, or much more simply, just subtract the 4.5 from the 90. So the absolute risk reduction, as it's called, is just the difference between the incidence before the vaccine and the incidence after the vaccine was introduced. So in this case, that comes out to be 85.5%. So in a sense, it's a measure of how effective the vaccine is. It's not what we hear in the news when they refer to efficacy. We'll get to that in a minute. Now, the relative risk reduction, that's defined as the percentage of people who would have become infected but did not due to the vaccine. So one way we can look at this is to describe this difference in here as a percent. Well, we did that already. That was 85.5%. And compare that with the 90% who would have gotten sick had there been no vaccine. So we could say that the relative risk reduction is the number or percentage of people, 85.5%, out of the 90% of the population that would have gotten sick had they not received the vaccine. Well, let's do that calculation here. I have a calculator all ready to go. So turning that on, we have 85.5. I can actually drop the percents. It'll come out the same either way. Divide that by 90, and oh my gosh, 0.95. So this comes out 0.95, which expressed in percent form would be exactly 95%. This is the vaccine's efficacy. This is what is meant when they report on well, later we'll see in a few minutes about how the Pfizer vaccine is also 95% effective. It's this number, the relative risk reduction. But it's quite different than the absolute risk reduction. Now let's talk about one final number before we move on into talking about the COVID vaccine. And that is what I find very fascinating. It's called the number needed to vaccinate. Now, I've given you a little formula here, which I'll try to justify in a minute, but it's quite simple. All we have to do is to divide 100% by ARR, that's the absolute risk reduction. And when we do, let's see what we get. That's let's round it off to 1.17. It means that 1.17 children need to be vaccinated in order for one child to get the benefit of that vaccination. In other words, belongs to the group that did receive benefit. Here's one way, another way I can justify this. If I look at it in the other direction, if I just say, okay, let's look at the ARR. If the ARR is 85.5%, then I can write that as 85.5 over 100. We can say that the 85.5 is the number of children who benefit for every 100 children who receive the vaccine. So 85.5 people benefit for every 100 vaccinations. If we turn it upside down, 100 vaccinations per 85.5 children who benefit, well, that's actually the very same calculation we just did, and we get 1.17. But now the units are easier to see. 1.17 vaccinations per each child who benefits, per one benefit. All right. 1.17 as a number needed to vaccinate is actually quite good. The best you can do, and the best you could hope for, is 1. Because if the number needed to vaccinate is 1, it means that each child or person who's vaccinated gets the benefit of that vaccination. Okay, with that under our belt, let's move now to COVID-19. Okay, so now we're going to take a similar look, but this time at COVID-19. Let's calculate those same numbers. First, let's begin with the incidence of COVID-19. Well, for this, we actually have to look to the Pfizer BioNTech clinical trial data. They had approximately 43,000 people to begin with. They split those into two groups, and In the end, they had, in fact, exactly 17,511 people who were in the placebo group who received no vaccine at all. And in that group, they actually had 162 cases of COVID. So if we divide 162 by 17,511, we'll find out what the incidence of COVID-19 was. And this was, by the way, over approximately 2 months. So let's get our calculator out. We see that the incidence is 0.00925, or 0.93, roughly, 0.93%. Now, the vaccine group, the so-called experimental group, had almost the same number of people, but they only had 8 cases of COVID in those 2 months. So if I divide 8 by, in their case, it was 17,411. Interestingly, they were exactly 100 people off, or different. And if we do that, let's find out what we get. So 8 divided by 17,411, that's 0.04, let's round it off to 0.046, 0.046%. And that would be the incidence after the vaccine was administered in the experimental group. Okay, so remember how with measles we drew lines to indicate where these incidents occurred in the population, the incidence rates. To do that on this, we're going to have to go down below the 1% mark. So if I make this really big, and each one of these lines represents 2%, 2, 4, 6, 8, 10. So 0.9 would be just below 1%, so somewhere in here. That's 0.93%. And then the other rate, the rate after the vaccine was given, was even less than that. I won't even try to get it correct, but it's right in here, just at the very bottom, 0.046%. Okay. Okay. So let's do what we did before and calculate the absolute risk reduction. And we found out that the easy way to do that was to just find the difference between the incidence rate before the vaccine was developed, 0.93%, minus the incidence after the vaccine was administered, 0.046%, and that should be 0.884%. That's the percentage of the population that will benefit from everybody getting vaccinated. Okay, so now let's take a look at the relative risk reduction. And the way we found that was to see how much different these two were, find their difference. Well, that difference we already know is the same as the ARR, and divide it by the percentage of people who would have been infected if there had been no vaccine. So we get 0.884%, and we divide that by 0.93%. Let's go to our calculator for that. And lo and behold, we get a number which is quite nearly 95%. So we get 0.95, I'll say 0.95, which is, in percent notation, 95%. And remember, this number here, that's the number that is known as the vaccine's efficacy. It's truly the relative risk reduction, not at all the absolute risk reduction. Okay, now we'll take a look at the third number, which is the number needed to vaccinate. And we have our little formula here, so it would be easy to apply it. We'll just take 100 divided by the absolute risk reduction, 0.884. And this gives us 113, roughly, 113. And that means that 113 people, I'm going to slow down and say this clearly because this is the upshot of the whole video. 113 people must be vaccinated to benefit one person, which is to say, to prevent one case of COVID-19. I personally think that that's astonishing. In this video, I've compared the measles vaccine with the Pfizer Covid-19 vaccine in 3 ways. They both have the same 95% relative risk reduction, which means that each vaccine reduces the number of potential infections by 95%. But even when the relative risk reduction is the same for 2 vaccines, their absolute risk reduction and the number needed to vaccinate to prevent one infection can be very different, depending on the incidence of the diseases. Just a word of caution. My comparison of COVID-19 with the measles is an imperfect one for several reasons. One big concern is that the incidence rates are measured over different time periods, about 2 months for the COVID-19 vaccine and who knows how long for the measles. Also, the 2 diseases impact totally different age groups, children for the measles and the elderly for COVID-19. Measles and COVID-19 are different diseases, obviously. In addition, different vaccines carry different risks, which we haven't addressed here. The numbers we examined in this video don't tell the whole story. I say this because I'm not pushing an agenda here. The choice to be vaccinated or not to be vaccinated is a personal one. To close, let's go back to my neighbor. Remember, he thought that because he'd received the Pfizer vaccine, he now had a 95% chance of staying healthy and a 5% chance of getting COVID-19. It would have been more accurate for him to have said, I had about a 99% chance of staying healthy over the next 2 months, and my risk of getting COVID-19 over the next 2 months has dropped to about 0.05%. And with that, I'll say goodbye and be well.